Okay, thank you for a nice introduction. My name is Michal, and Kuba or Jacob he will present some demos after my initial introduction. We are both from H2O AI, which is a company which is in Mountain View, and we are doing H2O. H2O is machine learning library, and we'll speak about it later because in this talk we would like to focus mainly on how we can deploy H2O models in production environment. And let's start a little bit with like our view of what's a scenario, what people doing, what we can see from our customers, how people deploying different kind of the models. So the initial pipeline, or we call it like the basic machine learning lifecycle, always contains something where you need to train a model. And train a model means then you need to take some input of data and prepare this data to the form which is acceptable by some machine learning training process. And this data preparation or data engineering often includes the operations like SQL joins or fetching data from different resources, combining them, and preparing to nice a table which you can push to next step of the process, which is actual machine learning training. And this machine learning training is often a process which contains a lot of experimentation and a lot of iterations. And the first step often is the operation which we call feature engineering. So you have your data, you understand your data, and you try to do something with them and extract some signal. And the something what you can do is filling the missing values. Typical operation if you have noisy data. Or if you have text data, you probably need to featureize or vectorize text data. And it's like nice operation which is normally done by every data scientist who needs to deal with data. And this is highly iterative job. So you have data, you try to different operations, and then when you are happy with your form of data, you pass the data to some machine learning algorithm. Again, it is highly experimental work. Machine learning algorithm has a lot of options, there's a lot of parameters, and you need to know how to set up them, how to deal with them, and how to understand them. And if you are happy with the state, then all this thing, we call it pipeline, can be deployed. So you prepare the data, you featureize, you do some feature engineering, you do model training, and if you are ready, you can deploy it. What it means deploy? So you have some training process, model building process when you prepare the pipeline. So for deployment, you need to record the same operations which you did during the training. So if you feel some missing values during the training, you have to repeat the same operation during the deployment, which is pretty obvious, but it was quite hard to do. The same for the model. So if you train the model, you have to have some form of the model which you can take and deploy to the production. And the deployment in the production can have different forms based on the technology. It can be Amazon Lambda, it can be REST service, it can be Azure function, whatever it's required by your business case. And this we call basic machine learning lifecycle. And since we are on the Spark Summit, this is perfect job for Spark pipelines. And we would like to show you how to combine the Spark pipelines with H2O. So Kuba will show you, in fact, two examples. The first one is the Spark pipeline, which contains H2O machine learning model. And this is the basic example when you keep feature engineering in the Spark. You are using powerful Spark data managing operations to prepare the data, and then you push the data to H2O algorithm. The second example will use Spark as well, Spark pipelines, but we will push whole featureization and model building to Driverless AI, which is another tool from the H2O ecosystem, which implements automatic feature engineering. And we'll show you what it means during the demo. So welcome Kuba on the stage, and he will show you the actual examples how to do these two scenarios with the Spark and H2O.
Okay, thank you, Michal, for the introduction. So I will start with the first implementation of our deployment, and it's using H2O and Spark. We call it Sparkling Water. So a little bit of introduction about this H2O and Spark. H2O is our machine learning library. We created those algorithms from scratch. They are all distributed algorithms such as like random trees, k-means, deep learning. All those algorithms have the same API unified. And the important is that this library is for machine learning experts. People, even though we have AutoML, automatic machine learning, people still need to understand a little bit of data science and need to tune the algorithms to perform well. This library also contains lots of advanced features for your needs. And on top of that, we have also Sparkling Water, which is built on top of Spark and H2O, and it integrates the best of both these tools. So we can take our algorithms, which are pretty accurate and fast and distributed, and integrate them with Apache Spark. So people can decide whether they want to use ML or H2O algorithms next to each other. And we try to integrate Sparkling Water with Spark pretty in a nice way. So Spark people, we don't have to learn new APIs and actually can use what we are used to do in Spark. So we can use H2O algorithms and H2O transformers inside of Spark pipelines in easy way. So that was a little bit of introduction about the Sparkling Water. And how does this fit to the abstract picture which Michal showed us before? So we can see that it's almost similar. We just see different boxes. We see the orange box, black box on the right side, and the last box down there. So the first box, the orange box, we can see that the feature engineering is done in Spark. So we can think of this such as maybe stop words remover in Spark pipeline, or SQL transformer, which we give it some data and we want to do data engineering and data cleansing in Spark. And for some reasons, because maybe we like H2O, we decided to use Sparkling Water and H2O to do the modeling phase. So the next stage is to take the features, take the transform data, and apply H2O model on top of those data. So that's the black box, and we create a model. The model produced by this stage is called H2O Mojo, and is the model which we put into production. And the deployment down there, it can be, as Michal said, a Lambda function, or we can use, in this case, Apache Spark, which accepts streaming data, and it will run transformations on those data on the input. And the data are transformed like in normal way as is in Spark pipeline. So we can, the Spark transformers, they transform the data. What is on the output, they transform it and create new column on the output. And the same holds for the H2O transformers. Even though they contain H2O algorithms, H2O models, they perform the same thing. So on the output, you can actually see the predictions. So it's actually really just regular Spark pipelines with extra H2O steps inside. And now I'm going to show a quick demo how this can, with this short demo, of like training this pipeline in Sparkling Water and the deployment of this demo of this pipeline. So let me just close these slides. Let me go here. I have prepared a Jupyter notebook. Maybe I can make it a little bit bigger. So I prepared a short Jupyter notebook, and we will just show how to train a really simple pipeline in Sparkling Water. So I just need to verify that Spark is running. I have a Spark running, it's in local mode. I just need to do some imports for PySparkling. PySparkling is our import, it's our wrapper for PySpark, our Python client. We need to start the H2O context. It's like Spark context for H2O. we need H2O context to be available for training the model. Okay, so we have a H2O context available. Basically, it started H2O on all Spark executors we have available. And now I'm gonna start defining the pipeline. So the first stage I'm gonna define is a simple SQL transformer. I forgot to mention the demo I'm presenting is we have some internal like machine learning processes, and what we want to predict is how long this machine learning process will take. So, it depends on specific platforms. For example, is it Windows? Is it Mac? How many rows we have? How many columns? And based on these metadata, we want to predict how long the machine learning process will take. So it's like meta application. So what I'm doing here, I'm just creating simple SQL transformer. And I'm filtering all the outliers because I'm not interested in a data which has less than 100 rows because they wouldn't make sense in our model. So I just created this stage. The next stage is defining H2O AutoML. So it's not Spark stage, it's H2O stage, but it's using the same API as Spark. What H2O AutoML does, it just tries to find the best model within the given constraints. So we give it 60 minutes and tell it, okay, give me the best model which you can give me in 60 minutes, 60 seconds. Okay, it's already defined. Now I'm gonna define the pipeline with the 2 stages I just defined. I'm gonna import the file. It went fine. I imported the file using H2O, so I need to transfer this to Spark data frame because we have different data formats. We do different operations than Spark, and Spark does different operations than we do. And now I can train the pipeline. It will take 60 seconds, and after that, when it's trained, I'm gonna export this Spark pipeline, and I'm gonna show you how we can put it in deployment. We can actually see that the AutoML is running here. You can probably catch what is happening, but we can see that lots of models are being trained, GBM, using research. Okay, so probably another 20 seconds. In the meanwhile, I can just prepare for the streaming demo. Okay, it should be done in any second. It's almost done. I would wait. Thank you. Okay, so we have the model available. Let me just export it. And now I'm going to show you how to deploy this pipeline. What the deployment means that we will start Spark application. We have a data which in S3. They are coming there from our internal infrastructure, from our measurements of the machine learning processes, and we want these data on the input from S3. So we are reading from S3 and running scoring on these streaming data. So what I can do, I can run this deploy Spark pipeline demo. It will load the Spark pipeline in the Python script. The Spark pipeline contains the Spark transformers and the H2O module model, and it will start doing the transformations on the data on the input. So it will probably return two empty boxes, but after that we can see that the output will start showing. So we can see the timestamp is just ID, and the predicted time is how long the machine learning process took, So we can see that deployment using this simple script is pretty easy, but the most important thing is the script, what is happening inside. So let me just quickly show you how this script looks. And I'll try to be as concise as possible. So the most important thing is this pipeline model load. because we are using just Spark pipeline. We are not doing anything else. We are not inventing anything new. Everything what we did is wrapped inside regular Spark pipeline, so you can use this pipeline with H2O steps inside your applications, inside your deployments. So we just load the pipeline, and here, because we are using Spark, we can use this streaming application and deploy it, and just run the predictions. So this was the first demo. Let me go back to slides. And the second way how we can deploy H2O applications is using H2O Driverless AI. And why? The original H2O is for machine learning experts, which needs to have some expertise of data science. But H2O Driverless AI can automate most of the things, such as people need to do some data cleansing, such as handling the NAs or target encoding. And these are the processes which can be automated, which H2O Driverless does. We have automatic feature engineering, which we created based on our knowledge from 6 years from our Kaggle grandmasters. And most of these processes can be actually automated, and the user doesn't need to know anything, how it's done inside. He just clicks, and we give him the best model given the specified constraints. So it's easy for people, they don't need any expertise in this area. How this fits into abstract original picture, so we can see that we have, again, the similar boxes, except that right now we use Spark just for the data cleansing and data engineering, and we use Driverless AI for both feature engineering and model training. And Driverless AI can figure based on specific application what the best feature engineering transformations should be done, and it will apply them and export them in the resulting artifact. And the deployment in this case is also very, very similar, except that right now we are not exporting a Spark pipeline, we are exporting a Driverless AI pipeline, which can be used as Spark pipeline. And this pipeline already contains all the transformers or the feature transformations and also the modeling stage, and can be used in Spark in normal way as Spark pipeline. So we can see that we just, the artifact which we produce from Driverless AI is called Driverless AI Mojo. It's how we store our models. And we can, again, use Spark to put this pipeline into production. So I'll just again show how we can put it into production. So let me just go back to shell. Let me again let me run the script. And let's first go here. So this is our Driverless AI interface. People start with this screen where they select the dataset which they want to use. So we have this Spark+AI Summit 2018, which contains the data from the processes of machine learning processes, and we want to run predictions. So I can click on predict. I need to select the target column, so I'm going to select the T total, which is the total time how long the process took. And I can see 3 knobs and a bunch of other informations, and I can configure the machine learning and machine learning processes. The accuracy specifies how accurate I want to be. If I'm gonna increase the accuracy, it's changing the feature engineering which can be applied. The same holds for interpretability. For some applications, we don't need interpretability, so we can use more features. We can see that some features appear here. If we want to increase the interpretability, some features will disappear because it's hard to explain them. And we can also specify time as a time constraint. So if we have more time, the Driverless AI probably decides to use 3 algorithms with higher depth, and it can maybe train XGBoost with again higher depth, and it will take a little bit longer. So I'll just specify time 3. I can see that this left side is changing based on the knob setting, and I can start the experiment. I'm not actually gonna wait for the result because I'm running it on CPU. When you have a GPU, Driverless AI makes use of it. and this will be like blazing fast, but on the CPU it takes a while. So I have the model already prepared. So let's keep this guy running. And let me again show you how we can deploy this pipeline, this driverless pipeline in Spark. So let me run this script. Again, it's simple script which starts Spark Summit application. It's starting with a Python script on the input, and the Python script is loading the pipeline, and we are just calling transform on it and passing it again the streaming data from the S3. So we can see that the pipeline was already loaded, and it will start showing results in a bit. So what we're gonna see here, again, the ID, which is the timestamp. We also gonna see the output from the previous pipeline, so we can compare the results. Important here, and the output from the new driverless AI pipeline. What is important to understand here that we have right now two concepts of like deployment and defining the stage, and the difference is that they are for like different audiences. That for driverless AI, it's all automated, and we can probably have better performance and better accuracy of the model because we put a really specific and optimized feature transformations, which we are not doing in H2O. So we can see that the predictions differ a little bit because we have different models, different transformations, and that's it. Okay, I'm gonna show before Michal takes the stage again. I'm gonna show you how the code looks like. Score both pipelines, and again I'll skip all the technical bits. And again I can see that I'm creating the module 2 object, which is actually Spark pipeline stage, and we can treat it as a regular Spark pipeline. And this Spark pipeline contains all the feature transformations and all the modeling stage created automatically by Driverless AI, so we don't need to do anything to create those. And again, I'm just running these predictions in infinite loop and showing the results. Okay, I'll keep this guy running, and I'll go back to slides, and I'll ask Michal if he can continue with the presentation.
Okay, thank you, Kuba. So you saw, in fact, two examples how to deploy H2O models as a part of the Spark pipeline. And this is our focus to follow Spark API to make it transparent for the Spark users, but embed H2O models. And H2O models, they are quite powerful with respect to the features. So if you need some advanced data machine learning, use H2O models. If you need some advanced feature engineering, use Driverless AI. And just example, you saw the first pipeline contained only a single transformer. And the second pipeline, which was generated by Driverless AI, the pipeline was found automatically. And this is, in fact, projection of the pipeline. So each edge is the data transformation or feature transformation, including some tree models inside. And you see that it's non-trivial pipeline, which is technically hard to deploy and technically hard to manage, and even hard to find all these transformation. So that's another message that if you need to do some feature engineering and you are not sure, you are not a skilled data scientist, you can always use Driverless AI to keep the work, export the result, and just embed the result embed the Spark pipeline inside, embed the Driverless AI pipeline inside the Spark pipeline and run it in your deployment scenario. What we described, in fact, was a basic machine learning lifecycle, but we understand this is really the baseline what right now people are doing. But of course, as you probably saw during the keynote, that the overall work of data scientists is much more complex. So there are like different stages, not only training and deployment, but there is also stages that you need to keep models versioned. You have to monitor them after deployment. Also, you need to document the process, how you get the models. And this is the overall platform what we are focusing right now. So not only training and deployment, but also allow the tools that you can generate documentation from your training process, for example, or store the models. And that's a perfect fit, in fact, for the Spark because of the ML flow effort or the effort in the rest of the Spark ecosystem. We nicely fit there with our H2O models and Driverless AI pipelines. So if you are interested in more resources, you can take a snapshot of this guy, and Kuba prepared a web page where you can find a lot of useful links or documentation or examples. You can try Spark in Water, you can download it and deploy some models. You can try Driverless AI to give you the best result from your data. And if you are happy, if you are unhappy, just let us know. We'll fix it or we'll improve it. And the message is, if you need to deploy H2O models, you can do that in the Spark quite easily. Just use Spark pipelines and let it run. Okay. Thank you very much. If you have any question, we are here with Kuba on the stage, ready to answer them.
Thank you for the talk. So I had a question regarding deploying the models that are trained using Spark, which use sparkling water. How do you deploy them for scoring without Spark? Is there?
Yeah, so that's a good question. What we intentionally show the work in scope of the Spark. And internally, we are using a format of the models which is called Mojo format. And this Mojo format is just description what the model contains. And we can take the description and deploy it without the Spark as a bare Amazon Lambda, or we can deploy it at the edge device if it is small enough model.
So basically the Mojo model of deploying models works with this stuff as well, even if the model is trained on Spark, is that correct?
Yes.
Okay.
Got a question about the architecture. Is my assumption that you will need a Spark cluster and also some other compute cluster for H2O, or so can you explain a little bit that?
Yeah, that's a good question. We didn't go to technical details, but conceptually, the basic Spark in Water installation, and Spark in Water is a way how to run H2O on top of the Spark. It runs a small or tiny H2O service inside each Spark executor. This is the basic mode. So you don't need separated H2O cluster. You don't need separated computation infrastructure. You just need a Spark job. You attach a Spark in Water library, and that's it. There is another mode, which in fact Kuba developed. It's a external mode. Then you can take Spark job and point to existing H2O cluster. And the main motivation for that, and I also mentioned during the keynote, that the workloads are different. So data managing workload needs slightly different infrastructure than machine learning workload. So we decided to split the infrastructure and say, okay, you can offload the model training to separated H2O cluster, which can be even shared between the several Spark jobs. And you can do the machine learning models there, but still in the Spark, on the Spark side, we need to have tiny H2O driver, which is communicating with the both cluster, with the both sides. So in fact, two deployments, one we call it embedded, directly on the top of the Spark. The second one is external. You have a bridge between H2O and Spark cluster.
Hi, hello. Is there an option to deploy the H2O model without using sparkling water?
Oh,
what is an option to deploy the H2O model in a Spark pipeline without sparkling water?
Without the Spark pipeline?
Without the sparkling water product.
Yeah. So as I mentioned that, the format of the model is independent of the platform. So you can take it and deploy whatever platform you have. So we call it deployment template. So we show how to deploy that as a REST service. We show how to deploy that as a Hive operation or Stormbolt, but it's always driven by the end deployment scenario. But the actual model artifact is independent of the target deployment environment.
Okay, just a follow-up question. Is the Mojo a proprietary of H2O?
Sorry?
The Mojo format, is that a proprietary of H2O?
That's our invention, but it's open. It's a zip file. You can open it. You can see whatever we are storing, how we are describing the models, and that's it. The decision behind that was that, just we have 1 minute, just to explain the decision. We did a lot of experiments with the formats like PMML or serialization of Python code, and all of them fail for the big models. And from our production use cases, we can see that people generating big models. And big models, I mean GBM model with 60,000 trees, or which are quite big to represent in XML via the PMML, or it's quite hard to manage as a scikit pipeline. So we have to invent a little bit our format.
Okay, thank you.
That's all we have. Thank you very much, Michael and Jacob.
Thank you.
Thank you.